Good day, everyone.
My name is Kyla Zirushana.
And I am Richelle Fabro.
And I am John Carsalva.
Today we're going to demonstrate our experiment,
which is the chemical reaction and
explain the chemical change happening.
So, this is the materials that we are going to use in our experiments.
This is food coloring, a vegetable oil, water, and
the spoon and the glass.
So first step, mix the food coloring into the vegetable oil. Next is prepare your glass of water and pour your mixed food coloring and vegetable oil, and you will see the result. This is the chemical change of water, oil, and food coloring. This is the magical underwater fireworks. So this is the chemical and physical reaction of magical underwater fireworks. Magical underwater fireworks could involve a chemical reaction between substances such as luminol and an oxidizing agent like hydrogen and peroxides. When these substances react, they produce light through a chemiluminescence reaction. So, the physical. The reaction would create a bubbles of gas and emits light, resulting in a stunning display of underwater fireworks. So hello, and our experiment is all about the volcanic eruption, and the material is...
So this is the following materials: dishwashing liquid, food color,
and the vinegar, the baking soda, the spoon which we are going to use this for stirring, and the water.
First step, I'm going to pour the water in our model volcano. Second step, the dishwashing liquid. Third step, the food color. Fourth step, the baking soda. Then you're going to stir the add some water. the last step.
The vinegar. Oh.
Tayo ka.
Liso.
This is the chemical change of our volcanic eruptions. Baking soda reacts with the vinegar to produce carbon dioxide gas, water, and sodium acetate. The chemical reactions can be represented as SCSS, which is baking soda plus vinegars. It equals to carbon dioxide gas plus water and sodium acetate. Food coloring doesn't chemically change the reactions but adds color to the mixture. So in the physical change, the release of carbon dioxide gas creates pressure inside the container, causing the eruption. The physical change includes the movement of materials such as bubbling and foaming and the release of gases. Intensive property of stone. In the case of stone, some common intensive properties included density. Density is the mass of a substance per unit volume. Stones have a characteristic density that remains constant regardless of the size or amount of the stone. The hardness. Hardness is the ability of a material to resist scratching or indentation. Stones are known for their hardness, which is intrinsic property of the material. Third is color. The color of the stone is an intensive property that remains the same regardless of the size or shape of the stone. Fourth is the melting point. The melting point of a stone is an intensive property that represents the temperature at which the stones change from the solid to the liquid states. This is the property that inherent to the nature of the stone and do not change with the quantity of the material. Intensive properties of metals. Metals, also known, exhibit several intensive properties that remains constant regardless of the amount of the metals present. The density. Like stones, the density of a metal is an intensive property that reflects the mass of the metal per unit volume. Each type of metals has specific density that is consistent. Second is melting point. The melting point of a metal is the temperature at which it changes from the solid to a liquid state. This property is intrinsic to the metal does not change with the quality of the metal. Next is electrical conductivity. Electrical conductivity metals are known for their higher electrical conductivity, which is the ability to conduct electricity. This property is an intensive characteristic of metals. Fourth is thermal conductivity. Metal also exhibit high thermal conductivity, which is the ability to conduct heat. Like electrical conductivity, thermal conductivity is an intensive properties of metal. 5 is malleability and ductility. Metals are often malleable, can be formed into thin sheets. The ductile can be drawn into wires. These properties are inherent to the metals and remains constant regardless of the amount of metals present. These intensive properties play significant role in defining the characteristic and behavior of metal in various applications.
Good day, here's another example of extensive properties, which is metals. So, extensive properties of metals refer to physical properties of metals materials that are dependent on the size or amount of the metal. Here are some examples of extensive properties of metals. First, mass. The mass of a metal sample is an extensive property. It represents the amount of metal present in the sample is directly proportional to the size of the sample. Second, volume. The volume of a metal sample is also an extensive property. It indicates the amount of space occupied by the metal and is directly related to the size of the sample. Third, density. Density is an extensive property of metals that relates the mass of a metal sample, its volume. The density of a metal is typically expressed in units of mass per unit volume. Example, grams per cubic centimeter. Fourth, heat capacity. The heat capacity of a metal is an extensive property that quantifies the amount of heat required to raise the temperature of a given amount of metal by 1 degree Celsius. Fifth, electrical conductivity. Electrical conductivity is an extensive property of metals that describe the ability of a metal to conduct electricity. It is influenced by factors such as the size and arrangement of metal atoms in the sample. Lastly, thermal conductivity. The thermal conductivity is an extensive property of metals that characterize the ability of a metal to conduct heat. It is related to the size and structure of the metal sample.
Some examples of extensive properties specific to wood include weight. The weight of a piece of wood is directly proportional to its mass, which in turn depends on the volume and density of the wood. If you have a larger piece of wood, it will generally weigh more than a small piece of the same type of wood. Next is volume. The volume of a piece of wood is the amount of space it occupies. It is directly proportional to the size and dimensions of the wood. If you have the larger piece of wood, it will have a greater volume than a smaller piece. Surface area. The surface area of a piece of wood is the total area of all its external surfaces. It is directly proportional to the size and shape of the wood. If you have a larger piece of wood, it will have a greater surface than a small piece. Next is the thermal conductivity. The thermal conductivity of wood is a measure of its ability to conduct heat. It is directly proportional to the density and moisture content of the wood. If you have a larger piece of wood, it will generally have a higher thermal conductivity than a smaller piece. And the last is flexural strength. The flexural strength of wood is a measure of its ability to resist bending or breaking under applied force. It is directly proportional to the size and dimensions of the wood. If you have a larger piece of wood, it will generally have a higher flexural strength than a smaller piece. These properties of wood are extensive because they depend on the size, dimensions, and the amount of wood present. They change as the size or amount of wood changes.